Yeah, hi everyone. I am Mohan Venkat. Today we are going to discuss about the minimum window substring problem. Okay, it is a classic coding interview question. My friend Jay Surya will explain about it.
Question asks us to find a minimum window substring of given string which contains all the characters of the second string. That means, uh, in simple terms, to say from a big string S, like V, G, F, H, I, T, B, V, like it's a string that they will give. Find the smallest piece that contains all the characters of another string T. Let's say T is with B. So we have to find the substring which contains all the characters like V, I, T, B. It should be there in this string. We need to give them the smallest substring that will contain all the characters in the T. So a real life analogy is if someone asks you to give the exact location of the chocolates finding place, like in any supermarket, like in DMart, you should you cannot say like you can find chocolates in DMart, right? So we have to say the exact precise location. So for that, you will say go to DMart. In DMart, for ground floor, in ground floor, you will be having so many racks. So you need to go to the chocolate rack in the ground floor. So that is what the precise location of the thing that you're searching. Similarly, you have to give the smallest substring that have all the characters in the string, given string that they asked us to map. So the brute force method is we will consider a character in string S. We will try all the characters from its place to all the characters to C, which will contains all the characters of string T. That means we will choose one character from string dot length. Like we will choose a character S first caret I equal to 0. Then we will check all the combinations possible with that character. And if we found the substring that we want, we will store it or return it. So similarly, we will check for all the characters in the string yes, which will be costing us nearly big of n square or n cube sometimes. So it's not a good code. So it will give us really for larger inputs that's expected for the brute force. So this is how the brute force will work. We will be given a string S, A, D, O, B, etc. something, and a small string ABC. So we will try all the combinations for letter A. A, it doesn't match the given substring ABC. So we'll check for AD, ADO, ADOB, etc. If any of the combination matches the given string, we will return that. So in this, two combinations are was possible: ADO, BEC, and BANC. But they asked us to give the minimum substring. In this both, we will choose BANC and we will return it. So this nested loop approach is not optimal because it will take big of n cube time complexity. So we need to switch to better approach. So stepwise solving of this question better approach is whenever will be given a question, you need to identify the pattern that the question is in. If a question asks for a minimum or maximum length of substring or subarray, you need to they'll ask to find the minimum window substring most of the times. Minimum or maximum length or minimum window subarray or substring questions. And if input is not negative, it will be most of the times it belongs to sliding window. So it's a trick we can remember. So whenever we find these words, keywords, minimum or maximum length of substring or subarray, and if the input contains all positives, then we can use sliding window. And we need to, whenever they say find minimum or maximum window, that means the size of the window is not fixed. So it can be anything. That means the another hint is it's a variable size sliding window, dynamic size sliding window. Before to state this, we need to understand that sliding window will have two types of approaches or methods: fixed size window, sliding window approach, and another one is variable size. So whenever they give a fixed size k in the question, we will follow fixed size window approach. If they say minimum or maximum, that means we have to use variable size sliding window. Both will have different templates. So in the step 2 of solving this type of questions, understand the condition. Window must contain all the characters of T with correct frequency. That means if store required information. So whenever they ask for a maximum or minimum length of substring or subarray, it belongs to variable size type, as k can be anything that we need to return. And the third step is information. Decide how to handle the information of window to check with what they are. We can store information either in variable or hash map or set, etc. Better use to maps because we need to compare the frequencies of the two strings. So step 4, we will initialize the window, length equal to 0, low equal to 0, minimum length equal to, it's in positive infinity, or we can say integer dot max value, start equal to 0. So expand the window, move right pointer from 0 to uh, s dot length minus 1. So that many times you have to move r from 0 to and s dot length minus 1. At each step, we will add the s of r to window and check if current window is valid or not. If it is valid, we will try to string the size of the window to get the minimum substring. So stringing the window is valid. Update minimum window size. Remove si from the sl from the window. That means whenever we are shrinking, we will move l plus plus. That means we will move the left value from 0 to 1, 1 to 2, like that, etc. So by moving L from its 0 to towards right side, we will remove those elements also, and we will again and again we will check if that substring is valid or not. If it is valid, we will continue shrinking. If not, we will come out of the while loop or shrinking window, and we will store the minimum string possible. So finally, after checking for all the R values, we will return the answer.
And now we are attacking the minimum window substring problem from lead code. The goal is simple, but the logic is deep. Here they given two strings S and T. Find the smallest substring in S that contains all the characters of T, including duplicates. We'll be using the sliding window approach with the two pointers and two hash maps. Uh, this allows us to solve it in a linear time of order of m plus n, which is the most optimal way to do. So first, let us think about this approach, how we are going to solve this problem. Here given a t, uh, let's create a map for it so that every character in the, let us think, if t equal to a, b, c, then we are going to create then we are going to create a hash map that counts every character in the string t. If here the string t contains a stores b1 and c1. For example, this is an example. Uh, let's like that. Let's create another map. Quickly create two hash maps and mm, make a variable uh, match, which will be the heart of the algorithm. It counts how many characters in our current window that satisfy the frequency requirements of t. Right? Let's quickly write the here. The map 2 is our window map. It tracks what characters we currently having in our sliding window, right? Mhm. Okay. Now we start a for loop with our right pointer I. This is the expansion phase. As we move I across, as we add a character to map 2. The key logic, if the character we just added by is needed by t, it's in map 1. Uh, and our character count in map is less than or equal to what we need. We increment match. This means we are not one step closer to here. The map 2 is our window map. It tracks that what characters we currently have in our sliding window, right? Uh, Now let's create some variables which will be useful for us. After that, we start a for loop with our right pointer, starting indexing I, naming indexing it as I. This is the expansion phase. As we move I across string S, right? We add the character to map 2, right? Here the key logic, if the character we just added is needed by T, it's in map 1, right? What we are speaking, we are talking about the map 1 characters, and our character count in map 2 is less than and equal to what we need. We need to increment match. Okay. This means we are one step closer to finding the valid window, right? Here, this is the key logic. Let's quickly write the code and check the uh, uh, how we are finding the valid window. We have a match variable here. This is the heart of the algorithm. It counts how many characters in our window satisfy the frequent requirements of T. Okay, let's check. Now we start a for loop. With now here we have completed a match variable. It counts how many characters in our current window satisfy the frequency requirement of T. And we have completed the for loop. This is the expression phase, as we have talked before. Here the current variable represents the current character of s at the index of I, which points to the uh, character at some point index. As we have talked before. Uh, the I moves from left to right. We have completed the initialize the hash maps, and we incremented the match by where match plays a key role in this here, right? It counts how many characters in our current window satisfy the frequency requirements of T, uh, right? We have initialized the for loop, right? Yeah, let's think now. Yeah, right. Yeah, okay, let's run the code once. Yeah, there is error 29. Yeah, is error at 9. Next, we have to see. You know, we have to map to make this right. Something we have to write any condition here that we have to check we whether the length is minimum or not. Right? We have the condition, right? So these all are here, and we have to over here, right? And not to here, right? Okay, I think it is fine now. Let's check once. We have just left character, and we have map to yeah, yeah. Okay, here we are going to have another if right? We have to write that statement. And lamp. What if lamp equal to? We have to write the max value. Okay, for wait, we have to string substring. If from starting to starting plus min, right? From the start or substring from start or start plus min. Okay, yeah, let's run the code once. Let's check whether it's running. Yeah, the total test cases came true. Let's submit the code. Yeah, right. The code is accepted here. Uh, Here, when check here, the right pointer moves in this for loop, right? It moves from A. From this example, if you look here, the string starts with the character A. From it map to so that I first map to A once. Okay, A is completed. Okay, okay. Here, the logic map 2 dot get A 1 is less than or equal to map 1 dot get of A, which makes that to become a map 1, right? Match 1. Okay, match will be increased as the condition is true. Now, the I moves from DOB, right? Okay, as per the for loop, it moves from character to character. Uh, as these DO are not in this, not in the T string, we can simply take out the D, O, and let's start with the B. right? It starts from the B. B are not in the map one, so match stays the same. When B hits map two, it again checks the if condition. What's that? Map two dot current value. Current value is current string character is B, and this is what and checks the map one dot get map one's character is B, right? So it increases. So match increases to two. Okay, so here match becomes one. Similar way, when the character is at B, match becomes two. In similar way, it moves from the it at the condition the character is at E, the condition will be false, and when the character hits C, it becomes three, and it checks whether the result matches. Don't we have the while loop, right? At starting the while loop fails because the length of the string does not match to the t dot length t dot length. So whenever as we know that t dot length that means the string t contains the length of 3 and the match length the match count is 3, so the both are the result is not true before, so the pointer I tries to make window smaller, right? It looks at a character at I, which is a. It removes a from map to the logic when we check the logic, map to get of a is now 0, and since 0 less than map to get of a, which is 1, the condition is true, right? So match drops, the while loop breaks, and we go back to expanding. So when we dive like this, we will get the required substring. Okay, hope you understand this one. Thank you.